In this physics video, we're going to be exploring what are mechanical waves. And this is sort of a little bit of a detail here about the larger picture that we've been talking about in our most common videos recently. And that is that energy can be transferred from one location to another. And we can do that via either particles or via waves. And with particles, we've already looked at things such as conduction and convection. And they can transfer energy from one location to another. But so can waves, and waves can of course involve particles as well, or they can involve just waves. And so let's check out mechanical waves, because mechanical waves are those that a wave transfer of energy from one location to the next, but involving particles. So let's check it out. So waves are just basically disturbances that carries energy from one location to another. And here you can see I've got pictures of common everyday examples of mechanical waves. So we've got a guitar string here. You can see that he's got a chord and the string here is vibrating, right? It's going up and down. Right, and that vibration is a mechanical wave. So the vibration in the string is a mechanical wave, and then of course those vibrations cause the instrument to vibrate, or the body to vibrate. In this case, it looks like a classical guitar, and as the body vibrates, it causes air to vibrate, and then of course we hear that as sound. Then we have the jostling of water molecules. So you can see a little fountain here, and as the water is falling back down, it's causing a disturbance in the water. And as that disturbance causes the water molecules to move up and down and jostle, that causes energy to be transferred through the water, and we can see ripples of waves going outwards. And we can see vibrating strings here, where of course we've got the good old can phone here, where you've probably made it when you were younger, talking through that. The vibrations in the string causes the bottom of the can and maybe the whole can to vibrate, and then we hear that as sound. So mechanical waves transfer energy in the medium that's present. Now, I'm going to highlight some words here and make sure you're doing the same with your notes. We've talked about the word disturbance. Well, what does that mean? We've talked about this idea of medium. Well, what is a medium? Right, because it says here that the mechanical waves can only transfer energy when a medium is present. Well, what's a medium? A medium is just basically matter through which energy passes. And so we've got different examples of mediums here. So air, so when I'm talking to you, the vocal cords are vibrating the air molecules. The air molecules are carrying that energy, and then it's being picked up by the microphone. The microphone has a little what's called diaphragm inside it, so the microphone gets moved backwards and forwards. That gets sent to an electrical signal, and then it gets recorded in the recording device. But air is an example of a medium. Water is another example of a medium. We have rocks, right? So rocks in the ground. So when elephants vibrate, those vibrations, those low vibrations of their body get sent through their legs into the ground and into the rocks, and that can transmit the energy from, or transfer the energy from one location to the next pod of elephants, you know, a kilometre or two away. We have steel, the ground, as we just said, and bones and tissues. So believe it or not, we can send sound waves through your body. Those sound waves cause the atoms in your tissues and bones to vibrate at different rates and transfer energy. And of course we can use those different vibrations and reflections of sound and everything to give us a picture inside your body. And so we know that a medium in that instance is the components of your body. So a medium is just a bit of matter or material through which energy transfers. So make sure you got that definition down there. So one big key idea here is that energy, that waves transfer energy and not matter. Okay, and so here you can see a quick little video here that I've done in a science show, where I've got a big long spring, and I've made a lot of continuous pulses on that spring and made what's called a standing wave. And so the energy from my movement of the spring up and down is going through the spring. That's causing the boy's arm to go up, just jostle a little bit. So the energy that I'm imparting into the spring is being transferred through the spring, but not the actual matter. So the individual bits of metal in the spring are staying in that one location. And you can see it again when I play it here, that the tip of this, and I'll play it in a second, the tip of this well, this trough here and the tip of the crest there, they're staying in one location, going up and down, whereas some locations are actually stationary. And so that's why we're calling it a stationary wave. But the key idea here is that waves transfer energy, not matter. Right. Another example is good old slinky springs, which we'll do in more detail in later videos. But you can see here that what I'm doing here is I'm holding the spring, I'm pulling the slinky back, and then I'm letting it go. And as I let it go, the energy travels through the slinky. Okay, and we can see that in the video here as well, that we can make energy transfer through a slinky but not matter. So in the example here, we can see that I've attached a little bit of tape. And that tape might move a little bit, right, jostle backwards and forwards or up and down, but the tape does not travel from one end of the slinky to the other end of the slinky, telling you that the energy moves through the slinky, not the actual metal material traveling from one location to another. And this is probably one of the biggest things to get your head around, is because as we're kids, we're used to hopping on our little boogie boards or surfboards, and we're used to being pushed to the shore by water. And so we tend to think that the water here on this wave is the same water that pushes through and reaches the shore. However, it's not. It's the energy that moves, not the water. The water does move a little bit, okay, in a circular fashion, but the water that starts out here is not the same water molecules that ends up on the beach. It's the energy. So let's have a look at another animation here. This one here is a common animation found on the web, where this shows you the movement of the molecules. And if you look very carefully, we can see that the energy moves through, but the actual colored dot, the actual molecule or particle within the wave, may jostle up and down or left and right, but it pretty much stays in that same location. And so we can have different types of these animations. We can have transverse animations, we can have longitudinal animations, but also with water, it gives us a circular sort of pattern. The water molecule stays roughly where it is. It doesn't move from one side of the animation or the screen to the other side. So to finish off, what are the three main types of mechanical waves? We're going to look at these in more detail, but let's just have a look. We've got transverse waves. Now, what are the key features that you have to write down in your notes underneath your diagrams drawn in pencil? This is what you have to do. That the particles move perpendicular, right? Particles move perpendicular, and I'm going to highlight that because that's so important. It moves perpendicular compared to the energy direction. So I've got my energy direction, which is going this way, but the particles right here is actually moving up and down. And so if I just change my color to pink again, this is going up and down, and we're going to look at this in more detail. Just like when I did my spring, I was moving the spring up and down, but the energy of the spring was going outwards, right? And so this gives us a transverse wave, because transverse means to change location, to cross a road. When you transverse a road, or a transversal in maths, right? So this is a transverse wave with perpendicular motion of a particle compared to the energy direction. Well, longitudinal waves are another type of wave. In fact, sound is a longitudinal wave. And so here, if we highlight the key ideas here, that the particles move parallel to the energy direction. Once again, the energy direction is moving that way, but my particles now are also moving in that sort of way. They're moving in the parallel direction. And we're going to see that in more detail in other videos. But that movement in the same direction is called longitudinal waves. And then we have surface waves, which are a combination of those two motions. So if we highlight again, that particles move parallel and perpendicular, and that produces a motion which is circular motion, and that is with water particles, and we saw that in that animation there. I'm just going to change to yellow here, and that means that if I have a particle in the water there, then that particle is pretty much going to be moving in a circular fashion, right? It'll move parallel to the motion, and then it starts to move perpendicular to the motion. And that movement around is circular. And so water molecules end up producing these round motions in their surface waves. We can also have surface waves in ground in the ground, and that's when we have surface waves for seismic waves. So there's a lot of new things in this video. How are your notes going as usual? Do you have the definitions written down in a side column for Cornell note-taking system like I've shown you before? Like the definition of what a medium is. Do you have the definition of the different types of waves? Do you have diagrams of our longitudinal, transverse and surface waves? Have you got a diagram that's very clear, that's labelled of those different types of waves? Because we're going to be looking at those in more detail. Can you have examples? Can you state examples of those different types of waves or common waves in everyday society? So check your notes out, make sure they're detailed, make sure they're structured and organized. They've got color there to indicate important terms that you need to memorize, and we can use all those techniques that we talk about in the study videos, such as the traffic light technique, etc., to really get your head around these concepts rather than just memorizing or doing, you're actually learning. All right, I'll see you next video.